All right, we've learned about how a monopolist sets price and quantity to maximize profits. Let's use this idea to think about this topic of markups, the markups of prices over marginal costs. There's what's called a rule of thumb for pricing with market power. The way we arrive at this, well, first we find an expression for marginal revenue in terms of the price elasticity of demand. Then we take this expression and set it equal to marginal cost. When we use that relationship, that will then yield an explanation of the optimal price markup over marginal cost in terms of the elasticity of demand. So first, let's get a new expression for marginal revenue. Revenue, as we've said many times before, is just price times quantity. Marginal revenue is the change in revenue with change in quantity. Now that has two terms. There's price, there's the price itself, then plus quantity times the change in price with a change in quantity. The way to think about this intuitively is that as quantity rises, there are really two effects on revenue. First, P times Q rises by P for each 1 unit increase in Q. And second, P times Q falls by Q times the change in price with the change in Q. That should say price there, change in price. Now, if you're a calculus buff, you'll recognize this as an application of the product rule. If you just have P of Q times Q, the derivative of that with respect to Q is P of Q times the derivative of that, which is just 1, plus Q times the derivative of P with respect to Q, which we in this course tend to call P of Q plus Q times delta P over delta Q. So that's where we get this expression, or this equation right up here. All right, moving along though, we can write it slightly differently. All we've done here is that we've taken this last term and we've multiplied it by P over P. The first term we left alone, it was just P. But by doing this, then we recognize that this term right here is something familiar. What is it? Well, it's 1 over the elasticity of demand. Remember, the elasticity of demand was the percent change in quantity with a percent change in price. This is just 1 over that. So that means that marginal revenue can be written as P of Q plus P of Q times 1 over this demand elasticity. And there we have it. Now we know that the way a monopolist maximizes profits is by choosing the quantity where MR equals MC. So let's do that, but let's do that using our new expression for MR. So here it is. Here's our new expression for MR, and we set it equal to MC. If we rearrange that, we can get the markup rule. And so that's what we're doing right down here. So we could rewrite this, we could derive it ourselves, P of Q, working from this equation here, minus MC would equal minus P of Q times 1 over the elasticity. But we could take that a step further by dividing both sides by P of Q, and we would get this expression, or this equation I should say, right here. And what does that say? The top part, P of Q minus MC, you know, the price includes, the price is potentially bigger than the marginal cost. Let's hope so anyways. This is just the difference between the price and the marginal cost. So that's kind of the excess of price over marginal cost, all divided by the price. So you could think about this left-hand side as the percent of the price. That's markup. And what we're saying is if the price is set in a profit maximizing way, that the percent of the price that's markup will equal minus 1 over the elasticity of demand. We can continue along here and a little bit more deeply into the markup. And we can ask the question, what's the profit maximizing markup when demand is perfectly elastic? So think back to perfect competition. The firm's demand curve looked like this. It was a horizontal line. And the elasticity in that situation is minus infinity. Well, when the elasticity is minus infinity, then 1 over minus infinity is just 0. And that means P minus MC over P is 0, which just means that P equals MC. And sure enough, that's what we had profit maximizing firms doing when they were perfectly competitive. But how about situations where there's some market power, where demand is less elastic? Well, as the elasticity comes up from negative infinity towards 0, that is, demand becomes less elastic or more inelastic, what happens is in this box, the profit maximizing markup is larger as the demand becomes less elastic. Now it's fun to take a field trip to the store. We can look at the markups on some branded products, and let's play the game. Let's see if we can figure out the price elasticity, assuming that they're pricing to maximize profit. Now to do this, we would need an estimate of marginal cost too. We don't know their marginal costs, but one thing we could do is we could look at generic or store brand products, figuring that those prices are close to marginal cost. At least that would give us some kind of a bound. So let's use that strategy. Here's a comparison of Cheerios, a well-known branded oat-flavored O-shaped cereal. And Cheerios is $3.99 a box. On the right-hand side, we have another O-shaped oat-flavored cereal that's same size box, actually same color box, which is a little troubling, and it's $1.98 for a box. Clearly a big difference in price. The question is, can we infer the elasticity of demand for Cheerios? Well, here again is our markup rule. Clearly, if we had P and MC, we could. We do have P. We know that the price of a box of cereal is $3.99. So if we just knew MC, we could calculate epsilon. Well, here's a non-crazy but not fully accurate assumption. Let's say the price of the store brand O-shaped oat cereal, $1.98, is close to the actual marginal cost. So if that were true, then, well, we could rewrite the formula, the markup formula, solve it for the elasticity, and we'd get the price of Cheerios, the elasticity equals the price of Cheerios divided by the marginal cost of Cheerios minus the price of Cheerios. Substituting in the price of Tostios as marginal cost, we would rewrite that as price of Cheerios divided by price of Tostios minus price of Cheerios. And so we'd solve that as epsilon c, or the elasticity of demand, equals 399 divided by the quantity, 198 minus 399. The answer is minus 1.99. In other words, we're inferring that the elasticity of demand for Cheerios is roughly minus 2. Now, since the marginal cost of Tostios is in fact less than the price of Tostios, that means the elasticity of demand is actually greater than minus 1.99, meaning closer to 0 or less elastic. Now if we go back to our scanner data on yogurt sales, we see, when the price of yogurt falls, the quantity demanded rises, and we've seen this before, and we actually got the demand curve out of this relationship. We actually can get these data, or data like this, on multiple brands of yogurt. And so if we were to compare those, maybe we can learn something about the relative elasticities of demand for the different products. So here's Dannon's demand curve, which we've seen before. So this is based on the statistical data on quantities sold at different prices. And we find this demand curve for Dannon. When we do the same thing for another major product, Yoplait, we get this demand curve. Now when we take and translate those demand curves into the way we usually write them, we get this picture. So the Yoplait curve is the red one, and the Dannon curve is the blue one. The Yoplait curve is more steeply sloped, which kind of looks like it's more inelastic. But let's see where that intuition takes us. And we can calculate demand elasticities using the formula that we've been working with for a while. I've reproduced in this picture just a reminder about what the average prices and quantities are for the two products. But let's start with Dannon. So the elasticity of demand in general is delta Q over delta P times P over Q. Here, that's minus 128,615.7 times P over Q. That P is 0.081 from up here, and that Q is the associated 3,500 and so forth. And the answer is minus 2.9. So the elasticity of demand for Dannon is minus 2.9. The elasticity of demand for Yoplait is minus 1.98. So punchline on this slide is that the demand for Yoplait is less elastic, which looks like Yoplait therefore has more market power. Let's go a step farther into this example and ask, can we infer the marginal costs of these products from their prices? Well, we know demand, and therefore we know marginal revenue, right? So if we have a description of the demand curve as a linear function, we can simply bisect it to get marginal revenue. We see the price that they're charging. So think about this as a picture of one of those products. We see that the price that they're charging, P star let's call it. Now, suppose that price is chosen optimally. If it's chosen optimally, then it's chosen in a way such that the marginal revenue at that quantity, Q star, is equal to the marginal cost. Well, here's the marginal revenue, and therefore the marginal cost must go through right there. So indeed, this is what marginal cost must look like. At Q star, marginal cost must be right at this level. Drawn it suggestively rising, but all we really know is that it has to be at this level, at this quantity. So yes, we can infer. It must be the case then that the marginal cost at Q star is equal to the level on the vertical axis implied by this relationship. So let's use the markup rule. The markup rule, as we first learned it, can be written this way. We can multiply, well, what we can do is we can sort of flip things around. So P minus C, if we multiply both sides by P, P minus C equals minus P over epsilon. Then if we isolate MC on the other side, we end up with MC equals P times the quantity 1 plus 1 over epsilon. So let's use our derived elasticities and just solve these formulas. And we find that MC for Dannon equals 0.053 or 5.3 cents per ounce. The MC for Yoplait is very similar. It's 5.1 cents per ounce. So they have very similar marginal costs, it would seem, but Yoplait has a much higher price. And why is that? Well, Yoplait has the more inelastic demand. Yoplait has more market power. We've been talking about market power. Now let's link this in with the idea of profit. Take a look at these two pictures below. They're meant to look identical. So when you ask the question, or when I ask the question, how does market power compare in the two pictures? We look at them and say, well, market power looks the same. The demands are the same. Therefore the elasticities of demand are the same. The markup of price over marginal cost at the monopoly price is the same. So market power is the same. But we can ask the question, what about profit? How does profit compare? And for that, we actually didn't have enough information until we put in the average cost curves. And the diagram on the left has an average cost curve that, well, at the quantity, the monopoly quantity, average cost is here. And so the average cost is right there, and there are profits. Whereas in the diagram on the right, the average costs at QM are actually equal to the price being charged. So there are no profits. Or to do it with a little bit less freehand, there, the shaded green region on the left is the positive profits. And on the right, we have 0 profits. Now, what's the point of all this? The point is that market power tells you something about markups, but profits depend also on fixed costs, which determine average costs. So you could have equal amounts of market power, but very different amounts of profit. So they're related ideas, but they're not the same. All right, so what do we take away from this module on markups? The first is, well, really summarized in the formula itself, the profit maximizing price bears an inverse relationship with the elasticity of demand, according to this formula. P minus MC over P equals minus 1 over the demand elasticity. Now that means that if you know the marginal cost and the elasticity, you can choose a profit maximizing price. It also means that if you know the price and the marginal cost, then if the pricing is being done in a profit maximizing way, you can infer the elasticity of demand. The last point from this little video has been that market power and profits are related, but they're not the same idea.